Hello everyone. In the previous videos we have discussed about the solutions of the problems on integration from exercise 7.2 of NCERT, and we have solved the problems up to question number 31. In this video we will be starting question number 32 and finishing the exercise today. Let's see question number 32. Here we have integral of 1 upon 1 plus cot x. What are we to do here? We have to find the solution, and for that, in case we take this particular function as t, we need its derivative, and the derivative of cot x is minus cos x square x, which is not available here. So we have to convert it into sine and cos, and we can write this as 1 upon 1 plus cos x upon sine x, because we know that cot x is cos x upon sine x. If we take the LCM in the denominator, and we will see that sine x will go in the numerator, so this will be sine x upon sine x plus cos x dx. Now in case we want to find out the solution of this by taking this particular function as t, the derivative of this sine x plus cos x, if we take this as t, sine x plus cos x is equal to t, suppose we take. Differentiating this, we are getting cos x minus sine x dx as dt. But here in the numerator we have only sine x. Can we get cos x minus sine x by some particular method? So what we will do, we can multiply and divide this by 2. And then we get here 1 by 2, 2 sine x upon sine x plus cos x. Why we have done this? See, we can write this 2 sine x as sine x plus sine x. And if we add and subtract cos x, we can get one of this part here. So what we do, we can write this as sine x plus cos x plus sine x minus cos x upon sine x plus cos x dx. Why we have done this? Because if we divide this sine x plus cos x by sine x plus cos x, we will be at here 1. And with this part, if we take minus common, this will become cos x minus sine x upon sine x plus cos x dx. And now what we get? When we integrate 1, we are getting x. So this is half x minus half. This is dt upon t plus c. We have already written the constant of integration as c here. And we know the integral of 1 upon t is log t. So we will get here half x minus half log of t plus c. If we take half common and substitute the value of t, we will get x minus log of sine x plus cos x plus c, which is the answer to the problem. I hope that you must have understood what is the trick to be applied in this particular question. Question number 33 here is similar to question number 32. The only thing is, in place of cot x, here it is tan x. The question is integral of 1 upon 1 minus tan x. The similar procedure we are going to adopt, and that is why I have already written the solution here. I am just going to explain it. See, we convert this tan x into sine and cos, and we know tan x is sine x upon cos x. So we get here 1 upon 1 minus sine x upon cos x. Taking the LCM and simplifying, we get here cos x upon cos x minus sine x. Now if we take cos x minus sine x as t, the derivative of it is minus sine x minus cos x dx equal to dt. If we take minus common and transpose onto the right, we get here sin x plus cos x dx is equal to minus dt. And to get this sin x plus cos x in the numerator, again we multiply and divide this by 2 to get 1 by 2 into 2 cos x upon cos x minus sin x. 2 cos x can be written as cos x plus cos x, and we add and subtract sin x in that. So we get here half cos x plus sin x plus cos x minus sin x whole upon cos x minus sin x. Now this can be divided into two parts. The first part is cos x plus sin x upon cos x minus sin x into half. Second part is half into cos x minus sin x upon cos x minus sin x. They cancel each other. If we substitute this particular value here, we are getting the first part becomes minus half of dt upon t, because cos x plus sin x dx is minus dt, plus half of 1, they cancel, which is equal to minus half log of t, because we know integral of 1 upon t is log t, plus half integral of 1 is x, so this is half x plus c. Taking minus half common and substituting the value of t, we get here minus half log of t means cos x minus sin x minus x plus c, which is the answer to the problem. Question number 34 here is integral of root tan x upon sin x into cos x. See, here we are finding root tan x in the numerator. If we take tan x as t or t square, the derivative of tan x is sec square x. But here in the denominator we have only cos x. To make it cos square x, we divide and multiply the denominator by cos x, which can be converted into sec square x. So what we do, we will be multiplying and dividing this by cos x, and we get root of tan x upon sin x upon cos x into cos square x. We can write here multiplying and dividing cos x in denominator. So we can write this as root of tan x upon tan x into sec square x, because we know 1 upon cos square x is sec square x. Simplifying this, we get here 1 upon root of tan x into sec square x dx. Now we can take tan x as t or t square if we want to avoid the radical power. Suppose we take it as t, so we write let tan x is equal to t, derivative of tan x is sec square x, so we are getting sec square x dx is equal to dt. Applying this here, we get 1 upon root t into dt, and we know the integral of 1 upon root t is 2 root t, this becomes 2 root t plus c. Substituting the value of t, we get here 2 into root of tan x plus c, which is the answer to this particular problem. 35th question is integral of whole square of 1 plus log x upon x. The question is very easy. We can say here that derivative of 1 plus log x is 1 upon x. It means we can take this particular function as t. So we take 1 plus log x as t. Differentiating with respect to x, we are getting 0 plus 1 upon x dx equal to dt. It means we are getting 1 upon x dx equal to dt. Applying it here, we get this as t square dt, and we know the integral of t square is t cube by 3 plus c. Substituting the value of t, we get 1 upon 3 into 1 plus log x whole cube plus c, the answer to this problem. 36th question is integral of x plus 1 into whole square of x plus log x upon x. What we find here? If we divide this x plus 1 by this x, do we get here 1 plus 1 upon x into x plus log x whole square? And we can see that derivative of x plus log x is 1 plus 1 upon x. So we can consider this as t. Considering x plus log x as t. Differentiating with respect to x, we get here 1 plus 1 upon x dx equal to dt. And applying this here, we get this into this is dt and this is t square. So this is t square dt. The integral of t square is t cube by 3 plus c. Substituting the value of t here, we get 1 upon 3. T is x plus log x whole cube plus c, which is the answer to the problem. 37th question is integral of x cube into sine of tan inverse x bar 4 upon 1 plus x bar 8. Here we have to remember that derivative of tan inverse x is 1 upon 1 plus x square. It means if it is x bar 4, the square of x bar 4 is x bar 8. So we can consider this as t. If we consider tan inverse x bar 4 as t and differentiate this with respect to x using chain rule, we will get here 1 upon 1 plus square of x bar 4 into d by dx of x bar 4. This we will consider as t here for derivative into dx equal to dt. Simplifying this, we get 1 upon 1 plus x bar 8. Square of x bar 4 is x bar 8 into derivative x bar 4 is 4x cube dx equal to dt. It means we will be getting x cube upon 1 plus x bar 8 dx as 1 upon 4 into dt. Applying this here, do we get x cube upon 1 plus x bar 8 into dx as 1 upon 4 dt? So this will be 1 upon 4 and this is sine t. So this becomes sine t dt. And we know the integral of sine t is minus cos t. So this becomes minus 1 upon 4 cos t plus c. Substituting the value of t, we get minus 1 upon 4 cos of tan inverse x bar 4 plus c, which is the answer to the problem. Dear friends, if you have not subscribed the channel so far, subscribe it to get more videos on the different topics of mathematics. Say here question number 38 and 39 are MCQs. Question number 38 is integral of tan x power 9 plus 10 power x into log of 10 base e upon x power 10 plus 10 power x. And 4 options have been given to us. To find the solution of such problem, we write the question first, that is 10 x power 9 plus 10 power x into log of 10 with base e upon x power 10 plus 10 power x. We can see very easily, if we take this particular function as t, the derivative of this is available here. So we can take this as t. So we write here, let x power 10 plus 10 to the power x is equal to t, or we can also take it as fx. As I told you, we can also use the formula f dash x upon fx. So if we apply that here, being this as the MCQ, we find here f dash x is, the derivative of x power 10 is 10 x power 9. And derivative of x power 10 is x 10 power x into log of 10 with base e. Because we know derivative of a power x is a power x into log of a with base e. And if we apply this here, the problem becomes f dash x upon fx dx. And we have already learnt that integral of this is log of fx plus c. Applying the value of fx, we are getting this as log of fx means x power 10 plus 10 power x plus c is the answer. But here we have to find one of the option. And out of these 4 we are finding D is the correct option. So we write therefore option D is the answer to this particular problem. The last question of the exercise, that is 39th question, is integral of 1 upon sine square x into cos square x equals, the 4 options have been given here. According to the options, we have to select the solution, and here since plus sign or minus sign etc. have been given here, so we will convert it into 2 parts. And for that, the easy way is we write the question first, 1 upon sine square x into cos square x. And we know that 1 can be converted to the form of sine and cos, that is sine square x plus cos square x. So we write here in the numerator sine square x plus cos square x in place of 1. And here it is sine square x into cos square x in the denominator. If we separate them, in the first part sine square x will cancel, and this will be 1 upon cos square x, plus in the second part cos square x will cancel, this will be 1 upon sine square x. We know 1 upon cos square x is sec square x, and 1 upon sine square x is cosec square x. We have separated both. The integral of sec square x is 10x, and the integral of cosec square x is minus cot x. So we write here minus cot x plus c, and we can write this as 10x minus cot x plus c. This is the answer to the problem, but we have to find from these options, and we find B is the option which is same as this. So we can write therefore option B is the answer of the problem. I hope that you must be liking these solutions with the explanations, and you would like to have more videos on this. Please share your comments. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.